Right now, KIC 8,462,852 is still dimming, unpredictably repeatedly, without a single pattern scientists can pin down, and NASA has no way to stop it. The smartest astronomers at Caltech and Yale have been watching it for over a decade, and what they found at the end of their data is the part they are afraid to say out loud. The star is called KIC 8,462,852. Most people know it as Tabby Star. It sits roughly 1,470 light-years away in the constellation Cygnus, close enough that our best telescopes can study it in detail. It was flagged by citizen scientists sifting through raw data from NASA's Kepler telescope in 2015, ordinary people who spotted something that should not have been there. Normally, when a planet passes in front of a star, the light dips by about 1%. Clean, predictable, temporary. But Tabby's star was doing something else entirely. It was dropping by up to 22%, at random, for days at a time, and then recovering only to do it again differently with no clear cycle, no warning, and no explanation. That is not how stars behave. That is not how anything behaves. The dips themselves were only the beginning. In 2017, the star faded by 3% in less than a week, not a dramatic eclipse. Just a slow, relentless dimming, the kind that suggested something was blocking the light, permanently. Astronomers at Louisiana State University launched an emergency global observation campaign and recruited telescopes on 6 continents to watch in real time. What they saw confirmed the disturbing part. The light was not just dipping, it was filtering. Blue wavelengths dimmed more than red wavelengths. That single detail eliminated half the theories in one shot. A solid object, a planet, a moon, a massive structure blocks all wavelengths equally. Whatever was in front of Tabby's star was not solid. It was dusty, diffuse, spread across a distance we cannot calculate and a width we cannot measure. But that's not even the part that worries them. So they went with dust. A swarm of comets, maybe billions of fragments broken apart, trailing debris between us and the star. It was the safest answer, the most comfortable explanation. And it almost worked, except for one problem. Dust absorbs starlight and re-emits it as heat. Point an infrared telescope at it and you would see a warm glow wrapped around the star. The astronomers checked. There was nothing, no heat signature, no infrared bloom. Whatever was absorbing the light was releasing no energy back. Something was drinking the starlight and going cold. That does not happen, not according to any physics we have ever written down. Not with any material we have ever cataloged anywhere in the observable universe. Here is the part they are afraid to say out loud. When researchers pulled historical photographic plates stretching back to the 1890s, actual glass plates, records from before radio existed, they found something that stopped the room. Tabby Star has been dimming for over 100 years. Not just dipping, dimming permanently. The star was measurably brighter in 1890 than it is today. It has lost roughly 14% of its total luminosity over the last century, slowly, steadily, continuously. On top of every random dip, every chaotic short-term eclipse, there is a long, quiet baseline fade that never stops. Stars do not do this. A main sequence F-type star, which is what Tabby's star is, should be stable for billions of years. It should not be fading on a human timescale. It should not be fading at all. But here is the strange part, and this is the piece that breaks everything. No known astrophysical process produces this combination. The short dips and the long fade do not share a cause. Every model built to explain the dips fails to explain the fade. Every model built to explain the fade cannot account for the dips. They are two separate, impossible things happening to the same star simultaneously. And the more data arrives, the worse the problem gets. Scientists are not closing in on an answer. They are getting further from one. If this were one bad reading, they would call it instrument error and move on. But Tabby's star has been observed by Kepler, by Spitzer, by Swift, by the Hubble Space Telescope, by Webb, and by ground observatories across the planet. Every instrument confirms the same result. Something is happening to this star that our entire framework of stellar physics says cannot happen. And that matters far beyond one strange star in Cygnus. Because the models we use to understand stellar behavior are the same models we use to date the universe, to calculate how long suns burn, to decide which distant worlds might support life. If those models have a gap, if there is a mechanism at work in our galaxy that no one has accounted for, then every calculation built on top of them is uncertain. Everything downstream moves. We do not know what is consuming this star's light. We do not know if it is natural. We do not know if Tabby Star is unique, or if it is simply the first one we noticed. And we do not know if it will stop. The question no one will answer on record is the one that lingers longest. What if it isn't? Drop your theory in the comments. We want to know what you think is happening to Tabby Star.